Coding made easy.
So what's up everybody, this is Peter aka Coding Made Easy coming to you guys with your next OpenGL Made Easy tutorial. So in this tutorial we're going to be diving right back into our C++ code. So at this stage of the game, this is usually when things take a turning point, in that things get really hard really fast, at least when I watch other tutorial series, because they throw a lot of things at you, right? Vertex buffer objects, vertex array objects, loading shaders, blah blah blah, and there's just so many things that are kind of thrown at you at once, and I want to alleviate that pressure, right? They don't call me Coding Made Easy for nothing. So basically we're going to break down creating a basic geometry over the span of the next few tutorials. So we're going to start really easy, and then we're going to progressively add a few things, and then hopefully by adding things chunk by chunk, everything is going to be explained well, and everything is going to make sense when they mesh as a whole, because you'll know how each individual part works. So in this tutorial, let me just get this image on the screen. So as you can see, I have a triangle here and I have a set of coordinates. So basically all we're going to be doing in this tutorial is rendering a triangle at these coordinates. So imagine we have this grid, a grid here, and this is the center of the grid, and we're just going to specify these 3 points, and we're going to draw this triangle on the screen. So that's all we're going to do. So how we're going to do this? Well, we're going to create some shaders. We're going to compile them. We are going to create the shader program, and then we're just going to run the shader, and literally that is it. And you'll see how simple it is to load and compile and run shaders in OpenGL. So hope you guys enjoy. So let's dive right in. So first and foremost, what we're going to do is we're going to include the string class, the stream for string stream, and the stream. And if you don't know what these are, feel free to watch my C++ Made Easy HD tutorial series. So first what we're going to do is we're going to create an unsigned int called create shader program, and this is going to take a constant GL char, and we're going to say vertex shader text, and we're going to say GL char fragment shader text, and we're going to create another function called load file contents, if I can type, and we're just going to pass in a what happened there? We're going to pass in a constant string for a file path. And let me explain what these are going to do. So as I've been telling you, shaders are programs that run on the GPU. So we have a vertex shader program and we have a fragment, and these fragment shaders, so these both combine, the vertex shader and the fragment shader combine to make our shader program. And so that's what we're going to be creating in this function. And the load file contents, all this is going to do is open up a file, take all the data in the file, and return it as a string. That's literally all it's going to do. So let's start with load file content, since this is the most boring thing to actually make probably. So let's get it out of the way. So load file contents, I promise it's a really short function. So we're just going to say string file path. And for those of you asking, in a later tutorial we're going to move these out of the main in the main file, and we're just going to do this in main for a little while, and then we'll start extracting it once we understand how everything works. So we're just going to say if stream, we're going to say file, and we're going to pass in the file path. I assume you know how the if stream works. And we're going to create a string stream, and we're just going to call it stream. So first we're going to check if the file is open. If it is not open, we're just going to do a simple, usually I don't know, maybe you want to throw an exception or whatever. I don't really care what you want to do at this point, but all we're going to say is cannot find the file, and we're just going to pass in the file path, and voila. Now, if everything, I guess we could put an else, but well, no, whatever. Anyways, so if everything goes well, then we're just going to say file.read buffer, and this is going to read the entire file buffer and pass it into our string stream. And what we're going to do is say string stream string. So we're going to pass the entire file buffer into our string stream, and then we're going to return the string, the actual string object from that string stream. Fair enough. So all this function does is it loads a file, gets all the contents, returns out the string. Simple, easy peasy lemon squeezy. So now let's get to the function that we're actually looking forward to, and that is to actually load our shaders. So let me just copy this from the actual top of the file instead of retyping it all. And sorry, I just for some reason thought I wasn't recording for a second. Okay, whatever. Anyways, so we've created our shader program. Sorry, we've created a method called create shader program. So now what we're going to do is we're going to create an unsigned int called vertex shader, and we're going to set it equal to gl create shader, and we're just going to say gl vertex shader. And all this does is that it creates a shader for us, and we're saying what type of shader we want to create, and it's passing in the ID, or it's returning the ID, which we set to this variable. And one thing that I forgot to tell you is, which I think I might have told you in the first tutorial, but I don't remember, is this thing called glchar, and as you see, glenum might confuse you a little bit, but the reason why OpenGL has its own predefined types instead of using the built-in types is to ensure that the size of the types is the same across every single system you run it on. As you may know, whenever you run if you use basic data types, depending on your computer and what type of computer you have and so on and so forth, the size can differ. With the built-in GL types, that doesn't happen, so they're the same size on every single computer. So just in case you guys were wondering. So anyways, let's get back into this. So gl create shader creates a shader, and we say what type of shader we want to create, and then it returns the ID. And we're going to do the same thing for the fragment shader. So we're going to say unsigned int fragment shader gl create shader, and what do you think this is going to be? Drumroll please. It's going to say fragment underscore shader, and voila, you guys have just created your first OpenGL shader. So that's it, you just created a shader, but you've just created an empty shader. So we need to actually find a way to pass this text, right, that we're going to actually load in from the file. We have to pass that into our shader, and we do that using a function called gl shader source. Oh my gosh, gl shader source. So we're going to say gl shader source, and if we look at the parameters, it takes in an unsigned int, and it's taking in first the shader ID. So we're just going to pass in the ID, and then the count is the size, or the size of the GL char array. In this case, we only have one, right? Because we're going to be taking the whole string and we're just going to be passing it in. Since it's a char pointer, it could technically be an array, and that's why they ask you for this for OpenGL to know if it is an array how many elements are in the array. So we're just going to set this to 1. And then what we're going to pass in is the vertex shader text. So this is a text we actually want to pass to our shader, and we're just going to put a null pointer there. And basically, this is the length of this. If we put null pointer, it's just going to take the whole it's just going to take all the text. So that's what we're going to do. And then we're going to put, after that, we're just going to say compile shader. and then we're just going to say the shader we want to compile. So what went on here? So we basically said, hey, let's create a shader. We created an empty shader, created an empty vertex shader, and assigned it to this ID here. We used GL shader source to pass the string data into our empty shader, sorry. So now our shader actually has text. So after it has text, now we actually have to compile it. So think of it as C or C++ or C code, right? Where, you know, we write the text in our code, so now we actually have to compile the code. Then after compiling the code, we have to do something called linking, which we will do in just a moment. So we've just compiled our vertex shader, and we're going to do the exact same thing for the fragment shader. And for the sake of time, we're just going to copy and paste. And this should be fragment shader text. And voila. So we just compiled the vertex shader and we just compiled the fragment shader. So nice, they're all compiled. But as I said, that we have to put these into an actual shader program so the shader program can actually be used. And when the shader program is used, then the shaders, the vertex and the fragment shader will run. So what we're going to do is up here, we're just going to create another unsigned int, and we're going to call this shader program. And I'm just going to say GL create program. And it takes no parameters. And what this does is create a shader program for us and pass the ID. So now after we're done compiling our shaders, what we're going to do is we're going to say GL attach shader. So we're going to specify the program that we want to attach the shader to, and then the shader to attach. So we're going to do that for the vertex shader, and we're going to do that for the fragment shader. So what this does is that it takes the shaders and attaches it to the program. Very simple. And as I said earlier, we gotta link it. So once we've attached those things, we just gotta link it, and we specify the shader program we want to link, or we pass the ID that we want to link, and voila. So assuming all goes well, we have our compiled shaders, and then they're attached to the shader program, and it's linked, and voila, we have a usable shader program, and that's it. So we have 3 more lines of code to write. So after we've linked the program, we're just going to delete the shader because we no longer need it. It's already compiled and linked, so we no longer need it anymore. So we're just going to delete that, and we're going to delete the fragment shader, and then we're just going to return the shader program ID. And literally that's it. So we have created empty vertex and fragment shaders. We have passed our text into those shaders. We have compiled the shaders, then attached them to the shader program, linked the shader program, and voila, our shader program is actually ready to run. So before we actually do something, we actually have to create our shader code, right? So what we're going to do is I'm just going to create 2 files. You can name them whatever you want. I'm just going to say shader.vert.glsl, and I'm going to create another file called shader.frag.glsl. And so let's take a look at the vertex shader, and I already have some code here, which I'm just going to copy and paste just for the sake of time. So at the top of the file, you'll see that I specified a version, right? So this lets you know which version of GLSL you're actually using, and we're using the core profile. So this has to be at the very top of the file. You need to specify the version at the very top. So after we specify the version, basically I've created a variable of vector3s that specifies these vertices that we saw in here. So as you can see, if we put this side by side, so we got -5, -0.5, -0.5, and 0 in the z coordinate. So this is this point in the corner. And the next one is we have 0, 0.50, which is the top right here. And then we have the right, which is 0.5, -0.5, 0. So these are the 3 points right here. Now, GLSL has a built-in has a built-in variable called GL underscore vertex ID. So remember in our second tutorial we learned that this vertex shader will run for every single vertex, or yeah, for every single vertex. And so this specifies the current vertex that we're actually on. So this is a predefined variable. So basically we're going to say if we're on the first vertex, GL vertex ID, it's 0 based. So first it's going to say vertices 0. We're going to get that position. Then it's going to be vertices 1, vertices 2. So we're going to get these 3 points. So that's what we're aiming for, and we're going to set that to the position. Now the fragment shader, I'm just going to copy what I have for the sake of time. Oh, did I put that in the fragment shader? Oh man. Sorry, this should be in the vertex shader. I was just testing you guys to see if you guys are being attentive. And here's the fragment shader. So now we specify the same version, and in GLSL 3+, we have to specify an output variable, and that output variable will be our color. So we set an out variable, it's our vector 4. So just like in vertex shader art where we set the GL frag color, this is the color we're just setting it to. So whatever the out parameter is the color of that pixel. And so we're just going to set this to a red color, and voila, so we got our vertex and we got our fragment shaders. And if any of this code confuses you a bit, I would say watch my previous 2 tutorials. It should give you some insight on what is going on. But even if you've watched those 2 and you're still a little bit confused, don't worry too much. We'll learn more about these in a later tutorial. So now that we've actually got our shaders, we're going to go back to our code and we actually have to load our shaders. So how are we going to do this? So below this, so once glue is initialized, what we're going to do is I'm going to create a string, and I'm just going to say vertex shader text, and it's going to be equal to load file contents, and we're going to load shader.vert.glsl. And then we are going to do the same thing for fragment shader text. We're going to load the file contents, and we're just going to say shader.frag.glsl. And so now we've loaded the file contents, and it should be stored in the string. And all we're going to do is we're just going to create an unsigned int. We're going to call it shader program, and we're going to set the shader program to create shader program. So we're going to pass in the vertex shader text underscore c string and fragment shader text dot c string, and voila, this should automatically create our shader program for us as we've created down here, and it should pass us the ID. So the last thing we have to do is we just have to say GL use program. And what this does is that from now on, whenever it's time for OpenGL to draw, it's going to use this program that we've specified here. So that's all we're going to do. So last but not least, let's scroll down to our actual draw function. So what we're going to do is we're just going to say GL clear to color, or clear color, sorry. And we're just going to set it to, I guess, black. So 0.0f, 0.0f, 1.0f, and I don't even know if we, yeah, and then we're just going to put GL clear. Don't worry about what's going on here. We're just going to put GL color buffer bit. And then last but not least, we're going to make a call to GL draw arrays. And if you remember from the actual vertex shader tutorial, we had to specify a hint in how to actually draw the, how to draw the points. So what we're going to do is we're just going to put GL underscore triangles. So this is going to hint to OpenGL that with the points given, we want to draw triangles. And this, we're just going to specify first is 0, and we're going to specify the count as 3. So if we want to set an offset or something, we could have set it as a different value, but for now we're just going to set it, we're starting at number 0 and we're going to 3. So this is basically saying that we're going to call our shaders, how do I best explain this? We're saying that we have 3 points that we actually want to draw. Basically, that is what's going on right here. So now that we've got that done, now we basically just need to actually run the application. So let's see what happens when we run this application. And we just gotta wait for it to compile. Oh my gosh. It's taking forever. And there's no way I can pause the recording, I don't think. Why is it taking so long to load the symbols? But anyways, while the symbols are loading, some of you might be asking, hey, okay, what if my shader failed to compile? Well, that is a true statement. So we have, okay, well, we'll address that in just a second. So as you can see, voila, we got a red triangle. So to address, so if you don't get this, or your shader doesn't compile, or you don't see anything at all, in the next tutorial we're going to be looking at how to find out what the compilation issues are. So if you are having compilation issues, stay tuned for the next tutorial. But if you've copied the code exactly how it is, then you should be able to see this red triangle in the window. So before we actually end this tutorial, let me just do a quick run through just in case you didn't get it the first like 100 times. So basically, what's happening is we're loading the file contents of these shaders we've created. So this basically loads the data and then returns a string. When we get to create shader program, we pass in that data from within the file, and then we create our shaders and we create our shader program. We pass the text data into our shaders individually. So we pass the vertex shader data into the vertex shader and the fragment shader data into the fragment shader. We attach these shaders to our shader program, and then we link our shader program so it does its magic, puts it all together, and then we delete the shaders because the data is already linked. We no longer need it, and then we return the shader program ID. So now that we got access to the shader program ID, the only thing left to do is actually tell OpenGL that we're using a shader program and what shader program to use. So we pass it in here. So any other draw call from this point on is going to be using the shader program. We get to here, we set the background to black. You can set this to whatever value you want to. We clear the window, and then we call draw arrays. So we hint to OpenGL that with the points we want to draw triangles, and we say we want to draw a total of 3 points. So that is it for this tutorial. I hope you guys enjoyed this. I hope this was easy enough for you to understand. And in the next tutorial, we're going to be expanding on this a little bit further and making our code a little bit better and a lot more robust. So that is it for this tutorial. Don't forget to comment, rate, and subscribe. If you're not a patron, don't forget to go on Patreon and become a patron. And if you are on Patreon, you will get early content and other cool perks that other people do not get. So that is it for this tutorial. Bye for now.